Man, Ashley, I can't believe you're in a library.
I know. It's so loud.
Really, it kind of is. Like,
Yeah, it's because it's like super big and open, and it goes like it has multiple levels. And
oh yeah, so it's like all open up. Yeah.
And then it all echoes.
Oh yeah. That's crazy.
Yep.
All right. Let's do this.
Okay. Oh, there's only 18 questions.
Yep.
Okay. Pretty sure I got the first two right.
Yeah, me too.
Okay.
I'm not sure. Okay, question 3. Requirements must be checked when conducting a hypothesis test comparing two means with independent samples. Make that apply.
Okay.
I think for sure the first one that a simple random sample was drawn from each population.
Mm-hmm.
It's not the fourth
Does it
one.
have to? Yeah, I don't think so. Do they have to?
Is it the second one as well? Like it's normal distributed from each group?
Oh, here I just found it in the book. So it says
okay.
a simple random sample was drawn from each of the populations, and X bars normally distributed for each group. So it's just the first two.
Okay.
I knew it wasn't the bottom one, so.
Yep.
Okay. I need to pull my book out real quick.
Okay. Question 4.
The test statistic
Okay.
hypothesis test comparing two means with independent samples is a, I'm guessing, a
T-score.
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 Okay. Two samples are independent if knowing which subjects will be in. Huh?
Oh, go ahead.
Oh, it's the second one.
That's what I was going to say.
The second one?
Yes. Oh, yay. Use an Excel doc to figure the next 6 questions out.
My favorite.
Yay.
At least it's not copy from whatever thing they're giving us in the test.
Yeah.
Oh, yeah.
No.
Mm-hmm.
Makes it a little easier.
Right? Okay, dental office.
Okay, I am.
Okay, so
Okay.
the degrees of freedom. How do we
That's
find
N
that?
minus 1. That's N minus 1.
Okay. In the book, though, it had the weird thing that was like the Satterthwaite approximation or something like that, and it
What did
wasn't
it
a
have?
whole number. It had like some weird thing that I don't even know how to pronounce it, but it was like the degrees of freedom weren't a whole number. Do you think that was because the
Oh, the critical value, you use the table with n minus 1 as the degree of freedom. Is that right? It was in the video.
So do we just use like the Rexburg dentist office minus the Idaho Falls dentist office?
Whoops.
I believe so.
And we're going to use the 2 sample t-test, correct? Right?
Yeah.
Oh, so we don't have to minus it. We just like put 2 samples in.
Yeah, it'll do it for us.
Oh, okay.
We just have to fill it in.
Wow, I wish these were some of my dentist bills, man.
I know. Actually, I'm super lucky. My uncle's a dentist, so he does all my dental work for free.
What?
Oh, that's awesome.
I'm so jealous.
I know, right? Like, I just got my wisdom teeth out before school started. I was
Oh,
like,
yeah,
there's
that's so expensive.
here's $2,600 out the window. So, 'cause I had to do
haven't get them
all
out.
4 of them. Oh, you're so lucky.
Yeah. I got all 4 of them out my senior year of high school, and it was pretty miserable.
Well, I lost my last baby tooth at like 22 when I got braces. So when they did like the panoramic, they're like, "Oh, you're the size it would be if you were 12, so you'll probably get them in your 30s," which happened. So,
That's funny.
all right. So did you guys do 0.9 and then not equal to? On the pasted the data where it has like the confidence level and then the type of test? Oh,
Oh, I didn't get that far yet.
okay, sorry.
So the confidence level, is it 0.9?
Yeah, it's 0.9.
Yeah.
And then do we use the equals? Do we put in
Well,
the alternative hypothesis or the null hypothesis?
I wonder if we do the less than, because the
Yeah,
equal
that's what I
sign
was wondering.
is not doesn't have the cross out over it, so it's not equal to. And they're wanting to know if the Idaho Falls office is less than the Rexburg office. So
Probably less than, okay, would be what we would use.
What about
Yep.
assume equal variances?
Okay.
okay.
See how it has a number for the degrees of freedom? It's like 37.996.
Uh-huh.
How did you get that?
So you just look at on the sheet. It has the degrees of freedom or the DF down in the bottom 2 sample t-test thing, and it has the numbers 37.996 in mine.
Mine as well.
I don't have it.
Do you want me to share my screen and show you where it's at?
Can you?
Yeah, here, let's see if I can figure this out. See how it's down here?
Oh, okay.
Mm-hmm. Yeah, so that's the degrees of freedom, and usually it's n-1, but for this one it's got it as some weird formula. It's like, look at how long that is.
So what does that mean for the assume equal variance?
Okay, I didn't hear that last
For
part
what?
because
Um,
at work,
the assume equal variance.
I'm listening.
Says.
Next question is snap back the person. I'm listening.
I have no idea.
Where are you reading that at?
Like the confidence level, type of test, and the one up below.
It says there should be no unless told otherwise. So we just leave it as no because we haven't gotten to that part yet of the class,
Yeah.
I'm guessing.
Gotcha.
About that. Okay, so we got that for the question 6, the 37.996.
How are you that tired?
That's what I have.
Okay. And then, okay, so question 7 says, what is the sample standard deviation for Rexburg? So we would just,
Or 208.875.
because Rexburg, right? Would that be
I think.
the one below?
Oh yeah. I'm sorry. Yeah,
So
Rexburg is variable too. Whoops.
oh, so it's 206.
Okay. Yeah.
Okay.
And then the test statistic is negative 0.434 for question 8.
Yep. Negative. Wait. I like having it do
And then,
the calculating for us. Makes it so much
yeah, it's
easier.
nice. Yep. And then same thing for question 9. It's asking what the p-value is, and we have it right there.
0.333. Yep.
Okay. And then what is the correct decision based on this evidence? Failed to reject the null hypothesis. Yep.
Oh gosh. And now we have to give evidence or statement. Oh wait, never mind. Suppose instead that you had used the alternative hypothesis, mu1 is not equal to mu2. What is the correct decision based on this evidence?
I think it'd be the second of insufficient evidence that the mean dentist bills between two cities are different. Fail to, or I guess we could switch that and see what it would be if it was not equal to. It'd still be the same thing.
Yeah, it would be the same.
Okay, so I think it's the second one.
Yeah.
Okay, next one, freshman dinner.
Woohoo! Utah and Colorado.
Oh good,
You
there's
guys have like freshman dinner? Like
what's that?
for high school, you guys have freshman dinner?
No.
No.
Okay. So we have to adjust the confidence level to 0.95. Oh shoot, I'm gonna have to relocate and find some plug in my laptop.
Did you say you have to play? It's not school time for you. Okay.
It has an outlet nearby.
Oh, gotcha.
So for question 12, what is the appropriate alternative hypothesis?
Oh, okay. Hold on. Let me read this. So mu one.
Okay, sorry.
I wonder if it would. I think it would be the second one.
Yeah, because it just says like a different number rather than like more
Yeah,
or less
it doesn't.
than.
It doesn't say more or less. So
Yeah.
so change it on my Excel. Not equal to 0.95. Not equal to. All right. What is the test statistic?
0.845.
Yes.
Did
What
you
is the
guys
Q?
does
Sorry, what was that,
the
Ashley?
n just for like the number up at the top, the summary statistics, does n make a difference?
Like the 12 and the 10.
Mm-hmm. Actually, probably not with the
Oh, yeah.
t-value since it's going off
Yeah.
or the t-statistic.
And then I guess it's interesting because that box next to the t value, equal variance is not assumed since there's 12 and 10.
Mm-hmm.
Huh, that's interesting.
Yeah. Okay. So for the p-value, I've got 795.
What? I have 0.411.
Did you update your confidence? Oh, whoops. It's probably mine. I didn't have not equal to. Okay, yeah, now I have 0.411.
Okay.
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 What decision do you make?
Priority.
I think we would fail to reject it.
Agree?
Okay, 16. Information. Determine a 95% confidence interval for 1 minus 2 and estimate for difference between 1 and 2. Include your answer below. determine the margin of error for this 95%. Oh, last time did you guys find out how to do like the margin of error?
Um, let's see.
So we would take the difference, or like the distance between the lower interval and the upper interval,
And
and
divide
then
by
we
2.
take 2.
And this is when, like, the negative 2.214, you have to add it to the 5.147.
Yeah. So, but you take the absolute value of the 2.214 because it's a negative number.
Yep.
So for the full distance, I got 7.361.
That's what I got. And then divide by 2, correct?
Yep, to get
3.68.
1.
Oh, so last time, like I just did like the difference between like those two numbers, and I didn't divide it by 2.
Yeah.
Okay.
So after you left last time, Vincent, Ashley and I got desperate, and so we text messaged Stephanie, and she got on with us and told us, yes.
That's
We were like,
cheating.
oh no, that is
That's not
using
cheating.
resources. We could not
Okay.
figure it out.
Oh, that's smart. I should have stayed with you guys.
It was like 30 more minutes, but hey, we got it. So, but yes, you're right. All you missed was dividing it by 2. So,
Ah, so close.
okay.
But thanks for telling me now.
Yeah, so now you know how to do it.
Okay, input the lower bound.
So just negative 2.214.
Mm-hmm. And then the upper bound would be 5.147.
Dang, I was all stressing over this quiz today, and this, like, totally, I get it. Yay!
Yeah.
Yeah. Yay.
All right, you have everything in there.
What?
Moment of truth.
Go to submit quiz.
So I missed
Submit.
the.
Okay, so we missed the last 2. And
Number
13.
14?
number 13.
Oh, wait. Yeah, 13.
Okay.
Well, that's a bummer.
Yeah.
Oh.
What's that?
Okay.
You will see the feedback.
All right, starting this bad boy again. Okay, so why would that T-score, hold on, what is that, 13? What is a test statistic?
I don't know why that would be different than what it had. Maybe we had something wrong in the.
Yeah.
When we put it in.
Well, maybe I don't know.
That's weird that that would be off, and then the p-value would be right, though.
Uh-huh. That's so weird.
Same with the same with
17 and 18?
Yeah, because we got the margin of error right.
Yeah. Oh, wait. Did yours have feedback on it?
Yeah.
Oh, whoops.
Your results should be close to the answer shown. Okay. I wish I knew what the heck SPSS was.
The answer is okay. So this is talking about like SPSS, which is something we don't even use in this class.
Yeah. Okay, so 16 was right. Input the lower bound. The answer in S is slightly higher than in Excel, so the answer given is the average between the two results. The results should be close to the answer shown.
That means we'll never get it because we don't know what it is in SPSS.
I am not above texting Stephanie and asking for help. So frustrating.
Let me look it up on Google.
That works too, I guess.
Oh, yeah, I guess so. Thanks.
I don't know what's that mean.
I think we were stumped on this one last time, too. Hey. Okay. Any thoughts, guys?
Maybe we should call Stephanie.
I think we might.
Okay.
Um, hmm.
I can't remember how she explained how to do it on the quiz on Tuesday.
Oh, did she explain that? The same? Was it the same problem?
Yeah, because we couldn't figure that one out too, and so.
Found some massive calculation online for the how to calculate the t-value.
Yeah. This is a paired sample test, right? The
This
one
is
from
the
Tuesday.
two sample.
Yeah, but the one from Tuesday was a paired sample t-test, right?
Yeah.
Okay. I just don't know how that's different.
I don't know. The test statistic wasn't the number that was halfway.
I mean, I see how we got the answer on the one from Tuesday. I was double checking it
Oh, I
just
think
to
I
see
know
how we
now.
did it. All right, what you got, Benson?
Nothing actually.
Oh, okay.
I got it. But,
All right, I'm text messaging her because I looked at what we did on Tuesday, Ashley, with the last two, which was the same question, and it should be that those numbers should be it. So
Yeah, okay.
and then I don't know about number 13.
Okay.
I mean, do you guys have any ideas or?
is it like I'm thinking about it might be how like they run the number because like if on Excel like if I show it one more decimal place it gives
Uh-huh.
it gives me a different answer.
Okay.
Like
Maybe that's
it's
what we need to do.
it's close but like not exactly the same. For example, like for the upper like the upper bound, it gives me 5.1475. So which means 1.148.
Okay.
That's what I'm thinking, but I'm not sure.
But if you go out one more, it goes 1746, meaning it wouldn't be rounded that far up.
Yeah.
I don't know. Do you think it's something to do with that?
I just don't like how the feedback compares it to the SPSS stuff because it's like we're not using that. So how is that even something that's being used as guidance? I don't get that.
Yeah.
Okay, is there something in the reading that talks about if you have uneven samples? I mean,
It's all it says about like test statistics in it is like the stuff that we've already been doing is like going through the book and stuff.
yeah. Okay.
Or going through the Excel and finding it that way.
I don't know.
Okay. See what Stephanie says. And I still don't understand why the test statistic would not be. Because it doesn't change if you have it as greater than, less than, or not equal to.
Maybe it has to do with the fact that it's the new minus that goes down at the bottom of the reading, talking about how talking about the confidence interval, and it says the confidence values for the unknown parameter in between there are two, and then notice that if mu1 minus mu2 equals 0, and then it goes on like that. It's 4.1.
Okay. Dang, it was going so well.
Mm-hmm. We were on a roll till we
I
weren't.
know. See, and the bottom sentence says software can be used to compute the confidence interval for a difference of two means with independent samples, and that's what this is.
Yeah.
Okay, I guess I would just try on it. I would sacrifice myself.
Oh, no, you don't have to do that, Vincent.
Let's try this. I think I might. I think I got it. I think I know. I don't know. Oh.
%95 confidence level. It's not that.
Yeah, I have no idea.
I don't either. H23 and I23. H23, I23. Okay. We're 95% confident the true.
I still didn't get it. Oh well. Oh well. Okay. Did you get a hold of Stephanie?
I texted her, but nothing.
Okay. Because I need to go home teach. So I have to go now.
Well,
Well,
this should have been. That should have been the answer. I don't know.
I don't know either.
Oh well. Okay. I need to get going.
All right.
Okay. Good job, team.
Yeah. We'll let you know if we figure anything out.
Okay, thank you. See you guys next week. Have a good
All right.
weekend.
Yeah, you too. Bye.
Bye.
I just don't know, Ashley.
Me again.
Huh?
No idea how to.
Well, then you look at the summary for the chapter 13. It says whenever 0 is contained in the confidence interval of the difference of the true means, we conclude that there is no significant difference between the two populations.
It said that our margin of error was correct, wasn't it?
Yes, the
Yeah, it did. It said
3.681. I don't know. I mean, should we try doing it by hand?
maybe.
And I'm like, I don't even know which formula we would use.
I know we don't have one for using two different or the independent variable ones.
Actually, we do. It was in the video, and they said it's not in the book.
I didn't get all the way through both
It's
the videos.
it's the hold on, let me see if I can. Hold on if it starts talking. It's okay, so it's t times the square root, and it's going to have a lot of numbers of the sample 1. Hold on. Okay, so it's t times the square root of the first sample standard deviation squared divided by the first sample size, plus the standard deviation of the second sample size squared divided by in the second sample size. That made absolutely no sense, but
That's okay. I'll look it up real quick and see.
but looking at it, it'd be the t-score, so the 0.845. Didn't we get that wrong? Did
Yeah,
we get that one wrong?
0.845, yeah.
So this says it's no good because it's wrong. Okay, the first. Okay, so X bar, that is the sample mean, right?
Yeah.
Okay, so we need to get the mean of the first group of variables, right? Okay, average. Okay, and then okay, can you see this right here? Let me see, wait. Okay, can you see this right there?
Yeah,
Even
hold
though it's
on.
probably backwards.
Can I? That's okay. Can I copy that down real quick?
Yeah, it's X bar 1 minus X bar 2 plus or minus the t times, and then all of that stuff under the square roots.
Okay.
Sorry, my handwriting's terrible right there, but
No, it's alright. I think I got it.
okay.
Okay, so using that, we will write, except it said our t-score was wrong, didn't it?
Yeah, so I don't. Dang it! Now we have to go get a t score too. Okay, but we can set it up for all the other numbers though. So
Yeah.
okay, so stamp. Okay. Wait, wouldn't the T be the... It's a critical value, and I have a note that says use the table because it's n minus 1 for the degree of freedom. Is that sounding
Wait, what?
familiar? I have a note on here, and it says the T is the critical value. Use the table, or you get the answer with the table, but it's n minus 1, the degree of freedom.
So
But I don't know what it would be with the 2. Oh, wait. Never mind. Ugh. I hate it when I take notes and I'm like, okay, I know what it means when I write it, and then we get to when you need it, and you're like, no, that's not so much. Any luck?
no. Yeah, I don't know what it would be if it's not what it's in the table.
I know. Okay, Stephanie emailed me back. So,
Okay.
so all right, let me email her real fast. So we're doing this number 13. Okay, hold on. I'm almost done writing the email.
Okay.
Okay, I sent it to her.
All right.
I mean, honestly, I went back and looked at our quiz, and I'm like, we did it the exact same way.
Man, we think it's so easy.
I know. You know what, Ashley? I wonder if this one we were supposed to put into the paired sample test. Because look at the
What'd
question.
you say?
Look at number right before number 16. Look at the instructions. Well, no, that would be because it says the mu1 minus mu2. Well,
Mm-hmm.
when you're looking at the sample test, it only has variable 1 and variable 2, but if you go to the paired sample test, it has a difference in there.
Huh. That's weird.
But if that's the case, how did we get the
Well, we wouldn't be able to do a paired sample test because we've got
Yeah.
12 and then 10 values.
and then also, how would we have gotten the confidence interval correct had we done it in a different sheet as well?
Exactly.
I'm so confused. Oh my gosh. Okay. I should have put on there. Also, we got number 16 correct, so we got nothing.
Yeah. Yeah, I don't know how that could be the margin of error if those aren't the confidence intervals.
Right. She can't jump on here with us because she's in her own group meeting, and I was like, oh, I'm sorry. So,
Okay. Well, maybe that group will run into the same problem then. And we'll be like, see?
not just us. What if there's something on the discussion board about it?
Maybe.
Oh, it says you can find t with the formula t equals x minus u. U? What is u? Divided by the square, or divided by the standard deviation divided by the square root of n. However, these two values will turn out to be different for the same exact set of data.
Is that on like the questions and discussions board?
Yeah, it's like the very first one.
Or question? Okay.
Okay, and then something that Brother Polson says is because somebody was having a problem with the Excel, that the confidence intervals and the p-values are calculated using the t-values, and we don't teach how to use t-distributions to directly calculate p-values and confidence intervals.
Well, that's nice. Okay. We'll see if any, like... So we need help with, like... with the chapter 2 stuff.
Yeah. I mean, for all I can tell, we did it correctly, so I don't know what the deal is.
Yeah.
So.
Okay. Have you heard back from Stephanie yet at all?
No, but I'm just looking at this question. It says determine a confidence interval for mu1 minus mu2, an estimate for the difference between mu1 and mu2. But I mean, even if you go back and use that other paired sample test or whatever, it doesn't really truly do it all the way because there's 12 for the first variable group, there's 12, and for the second, there's 2 or 10.
Maybe if we just manually put it in.
Like 14 and 14.
Yeah.
2.098 and negative 0.197 and 8.197. Just don't know. I guess we could go look at somebody else's video to see what they got.
Yeah.
See if they explain it. Oh my goodness.
Might just take a hit on this one. I'm not going to be able to work on it for a whole lot longer, so.
Yeah. Okay, would you still put this test statistic as 0.845?
I'm going to try and see if it's like the number that's halfway in between.
Mm-hmm.
Maybe. I don't know. I have no idea what it would be.
Me neither.
Yeah. I don't want to take anyone out, but yeah.
Okay.
Okay.
I'm just hoping she'll email back real fast.
Yeah.
I mean, I was like pretty specific, like this is what we got. You know, I just copied what we got and then said, this is what the feedback says, but it's giving us nothing. So
Yeah. This is one thing I don't like about online classes. There's really no one to help you, and
Yeah.
there's stuff like this.
Hmm.
Um,
Well, like, and the video is great, but when you're looking at the material and you're like, it's
this
like
isn't
Greek.
even close.
Yeah, it doesn't make sense at all, you know?
Yeah. I don't know what it would be.
Me neither.
But I'm just gonna try it again. And if it doesn't work, then
Yeah.
that's okay.
I mean, we already got an 89 on it. That's not that bad, but
Yeah, okay, same thing. They're wrong. No. I might get going.
alrighty. Well,
See you on Monday, and let me know if
Yeah.
she ever says anything
yeah,
about how
if
to
she
figure
lets me
it
know,
out.
I'll send you the explanation for it at least. So, anyway,
Thank you.
all right.
All
Good
right,
night.
see
Okay,
ya.
bye.